Hello, everybody. I'm Hassan Noureddin, a PhD student at the French Naval Academy Research Institute. I will be presenting our work on multiple views of semantic trajectories in indoor and outdoor spaces. With the rapid advances of IoT and the widespread adoption of mobile devices, several applications has emerged to collect location data. One of those applications is the mobile crowd sensing, where location data highly collaborate with related crowd sensed information, such as information on pollution, weather, or health. These collected data are available for humans navigating in indoor and outdoor spaces. When associating indoor and outdoor spaces with a unified modeling framework, it should consider different granularity and abstractions to provide sufficient flexibility of the data manipulation level and to support a wide range of manipulation according to each user's interests. While some users just want to visualize the data, others require either finer details or aggregated views. In this work, we answer the problem of how to extract multiple views from semantic trajectories according to users' interests. This work extends our previous work on modeling semantic trajectories in indoor and outdoor spaces, where we have modeled the indoor and outdoor spaces in a unified and hierarchical model to support a homogeneous and continuous representation for indoor and outdoor human trajectories. The semantic trajectory representation is multidimensional and matches trajectories to spatial dimension embedded in the spatial model. Different levels of abstractions should be considered to facilitate the derivation of different views and interpretations of semantic trajectories. The derivation mechanism extracts from a generic semantic trajectory representation different flexible views derived from the spatial, temporal, and contextual semantics. The concept depends on some user's interest specified on the spatial or the contextual level. For example, the spatial user interest denotes a set of layers, and the contextual user interest can denote a set of semantic contextual values. This favors a hybrid representation from micro to macro data representation and vice versa. We derive two view trajectories: the hybrid semantic trajectory based on the places of interest and layers of interest, where its graph representation is centered on the places of interest that can be different with different granularities, and the contextual based trajectory based on context of interest, where its graph representation is centered on the context of interest. And these views, spatial and temporal aggregation can occur. An implementation was realized and experimented with real data collected to monitor the individual impact of pollution on human health while moving in the urban environment under Polyscope project. We used OpenStreetMap data for outdoor spatial annotations and Vita generator for indoor synthetic data. After extracting the semantics and joining the sequences, the semantic trajectories are stored in Neo4j graph database. We realized an extension of the Neo4j query language with procedures to extract the hybrid and the contextual based views. 4 operations have been implemented. 2 examples are shown in this slide. The first one, extract a hybrid trajectories with the place granularity when there is a high level of NO2 exposure and a county granularities otherwise. The figure shows a piece of the results on the Neo4j interface. Orange nodes represent places of interest represented from micro to macro granularity, where time intervals are embedded. Blue nodes represent the contextual dimensions limited to NO2 semantic. When applying the second operation on the same portion of the trajectory, we obtain the contextual based trajectory on the activity context of interest. We can inspect the orange nodes representing the transition from bus to row, for example, and the brown nodes represent the spatial dimension. This highlights how spatial, temporal, and contextual aggregations can impact the trajectory representation to get multiple views. In conclusion, this work introduces a modeling approach to extract from generic representation of semantic trajectories multiple views according to a wide range of user interests. And as for future research, it will be oriented to apply the approach to real-time detection of patterns. Thank you.